So we have one more type of display to talk about for quantitative data, and that's a box plot. Unfortunately, we couldn't really talk about it before because we needed to define that whole 5-number summary and how to find those numbers quickly. But a box plot is a way to just graphically show that 5-number summary. So that middle 50%, right, our IQR, is represented by this box section of our box plot. Q1, median, and Q3. And then you're going to have whiskers. You'll sometimes hear this called a box and whisker plot that go out to the minimum and maximum value. And we actually interpreted one of these, and you guys interpreted it awesomely for both classes for that IV fluid. So this particular box plot shows the highest education level versus earnings. And like I said, just with the IV fluids, you guys could easily see that high school education has lower earnings than the bachelor's education, right? But now we have a way to break these down. Now, this is a traditional box plot. By the way, the other advantage to a box plot is that you can compare multiple groups. We've actually already seen this. Look at the last example we did with the stem plot. We did a back-to-back stem plot, and this allowed us to compare males and females, a categorical variable with a quantitative measure, right? How much they scored in this bowling tournament. So this allows us to do something very similar. We're looking at 2 different categories, high school and bachelor's versus earnings on a quantitative scale. The nice thing about box plots, though, is that you could have more. You could have master's and then PhD. You could have all these different levels because there's no limitation to the number of box plots you put on a set of axes versus those back-to-back stem plots, back-to-back histograms, back-to-back dot plots. Those all exist, but they only let you compare 2 groups. So the thing I'm going to have you do on a test, and this is the first warm and fuzzy question you guys are going to get all semester, that is that you're going to construct a modified box plot. So first thing I need to do is define what the heck a modified box plot means. So a modified box plot is going to actually test for and mark outliers. So that previous example that we had, I'll go ahead and I won't use this, I'll use the previous one, this one. This is just a normal box plot. This is actually not a modified box plot, and I can verify that because in a modified box plot, what we do for our test for outliers is we look at that IQR, right? That range of the middle 30%, or 50%, I don't know why I said 30. And we look about 1, so we try to draw a line that's about the exact same, and a half, so this is 1.5. IQR is above, and 1 and a half. IQR is below. And all of our data should fall in this range. That's where we consider normal or typical data. Any data outside of that range is abnormal. So whoever this maximum value is, that's an abnormal earnings to earn over 6K with a bachelor's degree. So that would not be marked with a line. What should happen instead is that we would mark that with an open circle, and then wherever the next highest earnings were, there might even be another person earning that much, we would have the rest of our box plot constructed from there. All right, that's what it would kind of look like. So we're going to make one of these. We do need that criterion, so it's all written here. This is something you might want to put on your note card, these 2 different Venn formulas, how we go above and below, because we don't do that visually, we do that mathematically. And then, but we're going to see this on the next page. So that's just the idea of a modified box plot, and we'll do an example on the next video.